protocol testing. In this video we will discuss about OSPF testing. So in the previous video, as we discussed, we will have we can share the routes between the router by using RIP, routing information protocol. Similarly, we can use OSPF also as the dynamic routing protocol to share the routes between the router and to take a decision of getting the shortest path to for reaching to a destination. So now we'll just check few basic test cases and we'll try to understand what kind of cases we can come up with OSPF. So here it is, OSPF neighbor shape check. Then OSPF route share with neighbor without radio distribute connected. Similar kind of case we have seen in the RIP as well. So same thing we'll try in OSPF also. So OSPF route share with neighbor with radio distribute connected, packet sent end to end, OSPF area concept and route share across area. So we have an area concept here that also we'll test here. So this theory part we already covered in the previous video, in the previous theory of OSPF video. So now this is the setup we are going to use. So as we can see, we have three routers here. Between router 1 and router 2 network is 2.0, between router 2 and router 3 network is 3.0, and this PC is 1.0 network and this side PC is 4.0 network. So we'll see that into packet tracer now. So as you can see here, we'll see whatever is configured in OSPF. We'll check the configuration here. If you see here, I think okay, so OSPF is not configured here. You can check by using this command as well. So it is not showing any neighborship, and we can see in the configuration as well, it is not showing. Instead it is showing RIP is configured. So what we will do, first of all, we will remove this configuration. deleted this rip. Now we'll check whether it is deleted or not. Show running config. Now we can see rip is deleted. Now what we have to do, we have to configure OSPF. So we have to go to configure mode. In the slide as well I have mentioned how to configure this OSPF. So there is how router OSPF 1. Router OSPF 1, and which network we want to configure. So we want to configure between router 1 and router 2. A network is there, that network we want an active in OSPF. This is the wildcard mask we have to give along with the network. Now OSPF is configured. We can verify that. So after every step we should verify whether whatever we have configured is reflecting in the running config or not. That is a good practice, and same thing you should follow when you are going into when you are writing a test plan or test case. Here we can see router OSPF network is enabled. Now if we will check for checking neighborship, we have the show IP OSPF neighbor plan, the router 1. So why it has not come? Because other routers are not configured. We have to go to other router as well. We have to see what is configured there. So we can see here OSPF is not configured here also, because that RIP is configured. So configure what we have to do, we have to delete this RIP. Now we'll configure OSPF. This configuration we have already made it ready, so we can directly give this. This 2.0 and 3.0 is the network between the routers. The router 2 is connected to two routers. We'll go to router 2 and here we give this. Here you can see the message 2.2.2.1 on serial 2/0 from loading to full state. So our OSPF neighborship has come up. Now so that also you can check. access 2.2.2.1 between router 1 and router 2. So in this router 2 we have configured two neighborship. One is toward router 1 side, other is toward router 3 side. So router 1 side it has come up, router 3 side it didn't come up because from in router 3 we have not configured that OSPF. So we'll go to router 3 also and we'll configure this OSPF. Now router width, and we configure this OSPF whatever we have given in the this. Now here also you can see 3.3.3.1 from loading to full. So now if we check in the middle router, that is router 2, both are into full state, 2.2.2.1 and other side 4.2.4.1. So one thing you can see here is so what you can see is even though this is 3.3.3.0 3.0.0.2 IP address configured here, but the router ID it is taking as 4.0.0. something 4.1.1. something. What is the reason for this? So the problem is, if you have not configured the router ID or loopback, what it will do, it will take the highest IP configured on the interface as the router ID. In this case 4.4.4.1 is the highest IP address, so that one it has taken. So one case you can write for router ID as well, that if loopback and router ID is not configured in the router for OSPF, if router ID and router ID or loopback IP is not configured, in that case it will take the highest interface IP as the router ID. So similarly, if any concept you are getting, you can plan a test case for that. So here you can see it has come to full state. So in this state it is showing which neighbor is reachable via which interface. So serial 2/0 we can reach to this particular neighbor. So this is our router ID of the neighbor. Serial 3/0 we can reach to host 4.4.4.1. So 2.2.2.1 is router 1 and 4.4.4.1 is router 2. Similarly, it will go to router 3. You can see here 3.3.3.1, that is middle router. That middle router you can reach via serial 2/0, that is router 2. So router 3 is having only one neighborship, that is with the middle router, that's router 3. It is having neighborship with router 2. So directly connected router are neighbor here. So router 3 is connected to router 2 and router 2 is connected to router 1. That's why router 2 is having two OSPF neighbors, because two routers are directly, two OSPF speaking neighbors are directly connected. But router 1 is having only one OSPF neighbor, because only one router connected to OSPF speaking router connected to router 1. Similarly for router 3. So This is one thing. So we check the OSPF neighborship. Neighborship check is successful. So we can say this test case is passed. So after configuring OSPF in all the router, our neighborship has come up. So you can come up with the manual steps. Like first of all, we have configured the IP address as mentioned in the configuration section. As mentioned in this configuration. So in this configuration, you can mention how to give IP address also to the interfaces, and then OSPF route share with neighbor without redistribute connector in the second case. But in this, you have to write down manual steps whatever you have done manually here. Now OSPF route share with neighbor with redistribute connected. So now it will see the route. So what you can see is 3.0.0 is learned by OSPF. We are into router 1, and where is this 3.0.0? We'll see in the diagram. This is the diagram. So this network is so what we can see, this router 2 is sharing 3.0 network information to router 1 via OSPF, because these two are neighbor. What he is doing, router 2 is doing, whatever network information router 2 is having, whatever OSPF network information router 2 is having, that is getting shared here. Similarly, if you see router 2 from router 3, router 2 to router 3, we'll see what information is getting shared. There is no information. Why? What is the reason? Because if you see in this diagram, these two, here we have configured OSPF. So these are the network which is part of OSPF. This is not part of OSPF. This is also not part of OSPF. So this will not get shared. You can see our configuration also. When we see a configuration in this router 3, only 3.0 network we have made the part of our configuration, part of OSPF, but this 4.0 is not made part of OSPF. Similarly, 1.0 in the router 1 is not made part of OSPF. 1.0 is not there. What we can do, this will not get shared by default. When you will give redistribute connected, so these are not OSPF routes. So it will be like, it will come as external route to OSPF. If you give redistribute connected, we'll see what happens. Similar like we have given backend rip also. We'll give that in OSPF also. After making this, we distribute connector. You can see here, see this OSPF route was already present before also, but now we are seeing this connected network information. Whatever was there in this connected route, this is not part of OSPF. Now it is reaching to router 1 also as an external route. External route means it is not OSPF route, so it is showing as E2. Okay, and it is reachable via serial 2/0. Similarly, it will go to router 3. Here also we can see this 2.0 network, 1.0 network, which is connected to EC0, which is connected to router 1. You can see here this router information, this route information is going to router 3 as well as router 2, because we have given redistribute connected. This is a connected route. All connected thing is going here, but it is not OSPF, so it is going as external. E2 means external. You can see E1 is OSPF external type 1, E2 means external type 2. That kind of configuration we can make, and we can change it to E1 or E2. This is what we can see. Now you can see the external, you can see the connected route directly into the OSPF database. Now you can see here also. Here you can see PC router 1's connected route is also come, router 2, router 3 connected route has also come. So we got 2 here. Okay, now we have these two things into the, you can give, and you can directly check OSPF route also. To show you directly the OSPF LAN type. So these are the OSPF LAN route into router 2. Similarly, you can see OSPF LAN route into so one is learned from router 2, one is from router, this is the router 2's route, and this is learned from router 3 to router 2 to router 1, and you can see the database also. Here it will give us detailed information of the LSS. LSS we have already discussed in the query section. Here we can see advertising router and kind of LSA like router link states type. So what all kind of LSAs are sent, those information should be there. So sequence number, checksum, age, this information will be there. So this is the basic thing. After these two got connected, how it is behaving. Now try to send packet, same thing we did in RIP also. So now what we'll do, we'll try to ping from PC1 to PC2. What is PC3's IP? That is 4.4.4.2. We'll try to ping. We have to check what is wrong here. Okay, what is wrong here? We have not configured the gateway here. So gateway is needed. You just configure the IP address, but you not configure the gateway. Here also same problem. First of all, we configure the gateway. One dot 1.1.2 we configured as gateway, and now here 4.4.4.1 will be our gateway. We can try pinging now. And now it is there. Again we'll try the same thing. So this end-to-end connectivity is working fine. What we can say, this case is working fine. Now we'll do this OSPF area concept. So you can see the configuration here. All these things whatever I explained is showing, like how the route and all these things will be visible. OSPF area concept and route share across area. Now we'll configure two areas. So area 0 is mandatory. So now we'll change to area 1. How we'll change it? This is the thing. It is simple. So one network is 3.0.0.0 will put it to area 1 into router 2 and router 3. This configuration is given clearly. So one network we are putting into area 0. So what will happen? We'll go to router 2. First of all, we'll delete this. Similarly, into other switch also, other router as well. We'll go into router 3 and we'll delete this. Now we configure that network into area 1. Now we'll see it has 3.3.1 area 2/0 loading to full. Now we'll see again that membership has come up. Now how we'll configure, how we will confirm this area thing. So by seeing the database. Here you can see for area 1 it is having one database. So router 3 is completely into area 1. Okay, so it is completely into area 1, but this router 2, it is an area border router. So area border router means it's one interface is in area 0, the other interface is in area 1. You can see here this part is area 0, this part is area 1. So this will be our border router. We call it as ABR. This also we have discussed in the theory section already. So you will see here in this router you will have database for area 0 as well as area 1. You will see here you can see we have two set of database. One is for area 0, one is for area 1. So area border router will need to maintain two database for two different areas. So the number of area it is configured, that many for every area it will have to maintain a separate database. So this is one thing. Now we'll check what is the route condition here. So here we should get one network summary LSA. You can see here, I'll show in the slide first. We'll see here, so IP OSPF database area concept will show different database for area and router too, that as we have already seen. Now if we'll see the route, so there is some issue it seems, and router 1 that configuration is gone. Maybe we would have done some mistake. We'll see what happens. It is not showing the route here. The area route should show it. We'll just check what is the problem here. You can see it should show with this tag, OSPF inter area routes. So we have to check our configuration again. What is the problem here? The configuration is fine. We are just replacing our routing table to see what happens exactly. If we go here in router 3, see here we can see this inter area route. So what is the thing? Into area 1, we are getting area 0's route. So what is happening basically, this 2.0 route, we are seeing it into this router as inter area route. So that we are seeing, but other thing, other routing information we are not able to see. I mean, this 3.0 network information is not going to router 1 as inter area route. So that we have to resolve why we are not seeing. So we are not seeing this. So there can be some issue, but before that we have to ensure our configuration is fine. Now we'll do one thing. We'll try configuring it freshly. And then we'll see what will happen. Sometimes that can also cause an issue. So sometimes it happens is like the older configuration, or you have to refresh the configuration. So now you can see center area route is learned. So this 3.0.0.0, previously it was learned as normal OSPF route or route as a router LSA, but now it is learned as inter area route, that is network summary LSA. So this part we just wanted to make it as a test case. So this thing you can make, and then there are several more concepts here in OSPF, like dead route, dead interval, hello interval. So you can write a test case for that also, like verify after every 10 seconds router is sending hello packet, or once router waits for 40 seconds for hello interval. If it is not received, it will make the neighbor down. So this kind of cases you can plan. And then age out timer is there. So after certain amount of time, router will make the LSA to flush out from the database, and router has to send the LSA again after certain interval of time. So those kind of cases also you can add in the test plan. This was just the basic of the testing concept to understand how to come up with a test case and how to identify the manual steps. Okay, thank you so much.